Since the dawn of humanity, we have been fascinated by time. We cherish memories of the past and dream of what the future holds. But what if we could actually travel through time? The idea has captivated our imaginations for centuries, inspiring countless science fiction stories, movies, and works of art. From H.G. Wells's The Time Machine to the iconic DeLorean in Back to the Future, time travel has become a staple of our cultural landscape. The allure of time travel lies in its potential to reshape our understanding of history, our place in the cosmos, and the very nature of reality itself. Imagine witnessing firsthand the grandeur of ancient civilizations, altering past events to change the course of history, or glimpsing into the future to see what destiny has in store. Albert Einstein's groundbreaking theories of relativity suggest that time is not absolute, but rather relative to the observer's frame of reference. This means that time can be stretched and compressed, warped and twisted under certain conditions. Could we one day unlock the secrets of time and journey through its corridors at will? Let us embark on a journey through the cosmos of physics, exploring the science behind time travel, the challenges and paradoxes it presents, and the tantalizing possibilities it holds for the future. To grasp the concept of time travel, we must first venture into the mind of Albert Einstein, whose revolutionary theories of relativity forever changed our understanding of space and time. In his special theory of relativity, published in 1905, Einstein proposed that time is not absolute, but rather relative to the observer's motion. This means that time can pass at different rates for observers who are moving relative to one another. Imagine two identical clocks, one stationary on Earth and the other traveling at incredibly high speeds through space. According to Einstein, time would pass slightly slower for the clock in motion compared to the stationary clock. This phenomenon, known as time dilation, has been experimentally verified using atomic clocks flown on high-speed jets and satellites. Einstein's general theory of relativity, published in 1915, further revolutionized our understanding of time by linking it to gravity. According to this theory, massive objects like stars and black holes warp the fabric of space-time around them, causing time to slow down in their vicinity. The implications of Einstein's theories for time travel are profound. By traveling at incredibly high speeds or venturing close to extremely massive objects, we might be able to experience time dilation firsthand, effectively traveling into the future. However, while Einstein's theories provide a framework for understanding how time travel might be possible, they also present significant challenges. While Einstein's theory suggests that traveling forward in time might be possible, traveling backward in time presents a whole new set of challenges. This is where the concept of wormholes comes into play, offering a tantalizing, albeit highly speculative, possibility for traversing the vast expanse of space-time. Imagine space-time as a sheet of paper folded in half, with two distant points representing different points in time. A wormhole, in theory, would be like a shortcut tunnel connecting these 2 points, allowing for near instantaneous travel between them. By traversing this cosmic shortcut, one could potentially bypass the limitations of traditional space-time travel and emerge at a different point in the past or future. The existence of wormholes was first predicted by Einstein and his colleague Nathan Rosen in 1935 as a solution to the equations of general relativity. However, these theoretical objects remain highly speculative, and their existence has yet to be confirmed. Even if wormholes do exist, their stability and traversability remain open questions. Despite these challenges, the idea of wormholes continues to capture the imagination of scientists and science fiction enthusiasts alike. Section 4. Time Travelers in the Lab. Experiments and Discoveries. While the prospect of building a time machine might seem like the stuff of science fiction, scientists have long been conducting experiments to better understand the nature of time and explore the possibilities of manipulating it. From atomic clocks to particle accelerators, these experiments provide valuable insights into the fundamental laws governing time and its potential for manipulation. One of the most well-known experiments related to time dilation is the Hufeld-Keating experiment, conducted in 1971. In this experiment, 4 atomic clocks were flown around the world on commercial airliners, while 4 identical clocks remained stationary on the ground. Upon comparing the clocks after the flights, the researchers found that the clocks that had been flown around the world showed a slight time difference compared to the stationary clocks. confirming Einstein's predictions of time dilation. Another area of research that holds potential implications for time travel is the study of quantum mechanics, the branch of physics that governs the behavior of matter at the atomic and subatomic levels. One of the strange and counterintuitive aspects of quantum mechanics is the concept of quantum entanglement, where two or more particles become linked together in such a way that they share the same fate, even when separated by vast distances. While these experiments and research endeavors have yet to produce a working time machine, they continue to push the boundaries of our understanding of time and its relationship to the universe around us. Section 5. Paradoxes and Puzzles. Untangling the Threads of Time. While the concept of time travel is undoubtedly captivating, it also raises a plethora of paradoxes and puzzles that challenge our understanding of cause and effect, identity, and the very fabric of reality. These paradoxes, often explored in science fiction, highlight the potential logical inconsistencies and philosophical dilemmas that time travel could create. One of the most famous time travel paradoxes is the grandfather paradox. Imagine traveling back in time and accidentally killing your own grandfather before your parent was even born. This seemingly simple act creates a logical inconsistency. If your grandfather died before your parent was born, then you could never have existed to travel back in time in the first place. Another intriguing paradox is the bootstrap paradox, which explores the idea of causal loops and self-creating information. Imagine finding a musical score for a beautiful symphony and traveling back in time to give it to a composer, claiming it is your own work. The composer then publishes the symphony, which becomes a timeless classic. Years later, you happen to hear this symphony, find the score, and decide to travel back in time to give it to the composer. In this scenario, where did the symphony originate? It seems to have no clear origin, existing in a closed loop of cause and effect. While the paradoxes of time travel may never be fully resolved, they serve as a reminder of the profound philosophical and scientific implications of tampering with the delicate fabric of space-time.